In this tutorial, we're going to add in the state system to turn this into a functional game. And with this, we're going to set it up and keep it pretty simple. So the object is going to be to survive as long as you can. So we're going to work on making it so that when we're playing the game, we play until we run out of health. And then we'll set up a timer so you're going to be tracking and figuring out how long you can survive. So the current state of our project right now is we have the unicorns who start out, and we have 10 of them, and we can update the difficulty in the game, and what we're trying to do is avoid them. So in our full version, we'll probably set it up to have more than the 10, but again, that's all part of figuring out the game. So the first thing we want to do is put in a state system. So we have a title state with instructions of how to play, and then we will have our game state that we're witnessing here, which will add some features to it, and then we will have a gameOverState. So this game isn't really going to be about win or lose, it's just play as long as you can, and then that gives you a score. So we can call it win, we can call it lose, or just game over. It doesn't really matter. If we follow what we've done in the past with our catcher project, where we had ways of winning and losing, maybe we can go down that road, but it's the similar kind of thing. So to begin, first, what we need to do is set up a variable, our string, that we're going to work with, and this string is going to be our game state. Now, gameState is going to have a couple of different options on it. We need to instantiate that. So again, as we add in variables, then we're going to take those variables and give them a value. And let's say gameState equals title. So we're using a string to represent this because we're representing a state. We could make this into what is called a constant. It takes a little bit more effort to do that. If we did that, then we could just do it without the quotes. But constants, which is what we're doing, a pseudo constant, are typically represented with all capital letters. So that's why I'm choosing to do that. So our options for this will be title, and game, and game over. So we're just going to have 3 separate states for this project. So currently we have our draw function here, which this is arguably this is our game that we have. We need to add more to it, but that is the game. And then we are going to put our logic to cycle through the states there. So we will be putting that into a separate function in a moment. So remembering how we broke things down in the past. Now here we have our key pressed, key released happening as well. We have the enemies chasing. We don't have the intersect going on this. They're just simply chasing. But they're using, kind of a distance algorithm to figure out how far apart they are, and then they chase based on what that distance is. So currently the distance radius we're working with is just if they're within 300 pixels, then the chase is on. So we will need to add in some rectangular intersection here so that we can find out when they're actually overlapping each other. So when that occurs, so first they chase, but then when they overlap, then we're going to want to kind of have a negative scoring effect take place, and we'll represent that as a health bar so that our health goes down. But first, let's get the basic state system set up into our project. With that, so we need to make a couple functions. So we'll have our void titleState function, void gameState function, and void gameOver function. So now we have our 3 states that we are going to work with on this, and then we'll just put some content into them and basically cycle through each of these states. So right now, all of this information here, so take it out of there, we're going to paste it in. So there's our game state, and our draw is going to say if game state is equal to title, then we will call our titleState function, else if gameState, and in this instance I'm using an if sequence here. We could just as easily use a switch sequence. We only have 3 states, so an if is just almost easier. So then we call our gameState function, and then else if gameState is equal to gameOver, and then within here we're going to say gameOverState, and then finally, or not gameOverState, what would we choose? Oh, gameOver. Let's see, the other ones, titleState, gameState, gameOver. We'll do it gameOverState. So being consistent or naming structures. Then finally, else. Say print line something went wrong with gameState. So we have that final thing. So if something breaks in our gameState, it will print out a message to the console so we know something bad is happening there. So this gives us a starting point of what we need. Now, what we can do, so we were using a basic string here with that string in the game. I was just filling that, setting that equal to, if we go down in our key pressed, we can see where we're representing that. So I don't think we really need that to happen anymore. So we're going to put something else in. So we're deleting that. I'm just going to put a comment down here, and we'll just call this section here utilities. This is where we're going to have our utility functions. So we have our key pressed, our key released. We're also going to then put in our intersect down here, and any other stuff that we're going to add. Now our titleState and our gameOverState are going to be pretty similar. We'll put some text on screen. We'll have a visual representation of a button so that we have an area that's clickable, and then once we click, then it will transition our state. So this is the kind of thing that we have done before when we were working on the catcher project. So with this, we're going to put in some text information here, and I'll do text align center. So if you remember, I mentioned constants before. Center, left, and right are 3 constants that are part of our text align method. So these are things that are predetermined in the program. That's why we don't put quotes around that value when it shows up there. And now we'll do a text size, and I'm going to just make it bigger. And I'm just going to choose a fill color. It's always a good idea before you draw some text on screen that you do reset the fill color to what you want it to be, because you don't know if something else has changed the size, changed the alignment, or changed the fill. So we can see within our game I don't have text align, so I will want to put a text align in here. Like that. Do left. We will be adding a variety of more things into our game state there, but that's just going to be our starting point. And now we'll just do a text statement here, and just say avoid the unicorns. And now if I choose where I want to put it, we do our X value, we'll do the middle of the screen, so I'll do width divided by 2. So it's centered, and then height, I'm going to put this down. Our whole thing is 600 tall, so I'm going to just put it down 200, so kind of a third of the way down. Now if we run our program, let's see what we have going on. We can see it puts text on screen. Now the text, you may notice, gets a little bit janky looking here, because what's happening is the anti-alias, the softening of the edges, the cleaning, so they're not crisp but look smooth, is being filled in as the edges are being redrawn 60 times a second. So what we really also want to do is have a background value here, and in this case, instead of 200, I'm going to use our color selector and just choose a color. So when I look at my color selector here, and we are going to leave the color selector out so I can find it later, and just choose this color here. And now I can see that I could just choose copy, paste. Now let's run it and see how it looks. That's a little bit better. Now I need to draw a button. I'm going to draw a button here. Now, in a finished version, I would encourage you to just design your whole screens in Photoshop and just bring an image in. And as long as you align the clickable area where you put the button inside of Photoshop, then things will line up. So as long as your kind of coordinate system matches to where you create the artwork in Photoshop of where the button is, then all is going to work. So now what I'm going to do is say fill. Now we have, oh, I forgot to copy the new color. Copy that color. And then I will do a circle. And in this case, we're going to, our text is at 200. So now I'm going to come down. So I will do 400, which is the center of my screen, or I could do a width divided by 2. But I really do want to do 400 here just so we can see the numbers we're working with. And 300 down, like this. Oh, and we see it's float, float, float on a circle. I forgot I need to put in the size of the circle. I have the X, Y, and then I want to put in the size on it. So let's go 100. And now if we run this, we'll see that, whoops. Oh, my numbers are off, and wow, that's a really big button because I thought it was size first, but it's X, Y, then size. So let's try again. So we'll go 400, 300, and 100. Now let's run it again. We can see now it puts it kind of in the center of the screen. So we've drawn a circle there. Now the next thing I want to do is listen for clicking on that space. And to achieve that, what we're going to do is we need to figure out how far away the mouse is. So if the mouse is being pressed and, so we say and with the 2 ampersands, and our distance from our click is less than 50. Now, we haven't defined what distance from click is yet, so we're going to do that in just a moment. See, it turned out red here. So let's just go up one line and define that. So we're just going to define. Now we could put all of this inside of here, but I think it's easier and it makes a little bit more sense, or it makes the code more understandable if we separate this out as its own variable. So we use the built-in distance function. This is exactly how we did it when we were building the catcher project. And then we check the mouse X and the mouse Y as one location, and then the other location is going to be where we drew our button, which is at 400 and 300. So what we're doing is we're calculating what is the distance between the mouse and this point on screen. That point on screen happens to be the dead center of that circle. So if the mouse is being pressed and our distance from click is less than 50, and remember that circle is 100 wide, so it's 100 wide, so as long as we're within 50 of that, then what we want to do is say gameState is equal to game. Going back up here, we have our 3 different options for our gameState. So that now sets up my gameState. All right, so now let's test this. So it doesn't work, doesn't work, doesn't work, doesn't, and now it works. Okay. So what I'm going to do is just copy all of this, my titleState, and I'm going to put this inside my gameOverState. Now I'm going to add in a couple closing comments here on my states and say end gameOverState. So we know that that curly brace and that curly brace go together. So now let's go here. This will be end gameState. Once again, if I click by that curly brace, we see it has its partner. Let's go up here for a titleState and titleState. So adding these in, I do believe, makes things a little bit cleaner. So now let's enter gameOverState. We're just going to change this to a new message, and I'll say great job. And what we're also going to do is put a line break in. So we'll say great job. You survived for, and now we're going to have a value that we haven't defined yet, but I'm going to just put it in. Well, we'll put it in a moment. We'll just say for a long time. We're not going to say what it is yet, and then just to see if that state is working, I'm going to put our initial state to game over. I also want to change the background color from pink. I'm going to change it to this blue color. So I'll go into our gameOverState, paste in that blue color, and I'm going to make my color, because it's a darker blue, so I'm going to make my text white. So now let's run it and see what it looks like, and we can see, great, you survived for a long time. Now, 2 options here. We can see we got some overlap happening. So what I might want to do is either pull the button down or push the text up. So I can look at my 2 options here. Design-wise, I think I like moving the button down. So if I move the text up, I change its Y value. If I move the button down, I change the the Y value here. So if I move the button down, say 100, changes to 400, and I have to change it inside my distance from click as well, so that those numbers match. So where I draw this circle and where I'm checking where the mouse is, those two things always have to match. Now let's run it again and see what it looks like. Okay, that looks a little bit better. So instead of for a long time, we're going to say for how many seconds you survived when we add in a little kind of health countdown timer. So we're keeping track of how long you're surviving, and then have, in effect, negative scoring happen as the game is continued to be played. So right now, we'll go back and set our starting state to title here. So our title state is done until we replace the basic text version with, well, something went wrong with gameState. Okay, what did I... I spelled title wrong. See, this is why we put stuff like that in our code. See how it says something went wrong with gameState, and we change it, and boom, there it is. Okay, and then I can click, and now we can play the game. But we don't have any way to win or lose yet, so that's what we want to work out next. But we can see we have our game states integrated now into the project. So the states are there. We just need to make it that we can play a little bit more and enter into a gameOverState. So the first thing I want to introduce in here now is another utility. This will be my rectangle intersect. So a rectangle intersect returns a value of true or false. So we had our circle intersect that we used inside our catcher game. Now we're doing a rectangle. So rectangle intersect, and we pass into it the player, and I'll call this R1. So we'll reference the player inside our code using R1, and then an enemy instance will be R2. Using this method of R1 and R2 does make it a little bit easier. Now we'll get the red underline right now, because until I put in a statement that says return anything, because remember, this doesn't say void like key pressed and all these others, it says Boolean. It's waiting for a return. I put in my comment there, and then I'll just say return false. So initially we want it to return false. It's only if there's an overlap does it return true. Now we'll see these little underlines here, and if I put my cursor over it, it says the value of the parameter is not used, but we're going to use it in just a moment. So what we have to do is we have to do 4 calculations. We want to calculate how far apart the two objects are on a horizontal or x-axis, how far apart they are on the y-axis or vertically, and then we need to figure out what is the combination of half of each of their widths and half of each of their height values, because then we use those in our calculation to determine if they are indeed intersecting each other or overlapping. So I have just a little demo program here which shows 2 rectangles. So these rectangles, the red dots represent their centers, and we can see I have some values here. Their distance of center on x-axis, y-axis, the combined half width, combined half heights. So we can see the boxes here. The red box is 50 wide, 100 tall. The blue is 150 wide and 50 tall. Therefore, their combined half heights are going to be 75. 50 for the red one, 25 for the blue one. Their combined half widths will be 100, because the red one is 25 and the blue one will be 75. So those are the 4 values we're trying to calculate. And now we can see the distance apart these objects are. So when I move them close to each other, we can see the distance on the x-axis apart. So we can see how close they are. And what we're determining is when the distance of their centers, those red dots, when the distance of the center is less than the combined. So right now the distance of the center is 102. And when that is less than half of their widths, we can see horizontally they're overlapping. Now vertically we can see they're overlapping when the distance of their heights. So right here, if I go to 76, we can see how they're not overlapping. But if I go less than that, see 72, we can see they're overlapping on the vertical axis. But an intersection only takes place when they overlap on both axes. So the screen turns green when they are indeed overlapping. We can see how I'm right, touching but not overlapping. The moment I go intrude here, we can see how they're overlapping. So we have to calculate these distances and then determine if that intersection is indeed taking place. So going back into my code, we're going to work on building out this function. So wrong, there we go. So distance on x, we need our distance on our y-axis. So our combined half widths, our combined half heights. And once we know these four values, then we're going to check for intersection. So that is the process we're going to use. So let's figure out each of these things. Distance on our x-axis. So we'll just say distx is equal to, and what we don't care whether it's a positive or negative value. So what we do is we subtract their two x values from each other. And in the process of doing that, we're able to then calculate that. But we need to make sure we're getting just a fixed number, not a positive or a negative, because we don't care whether we're overlapping positively or negatively on it. We just want to know what is the distance apart. So we can see here when I come in on the x, the distance on x, we're right now at 101. See how we're almost overlapping. Same way here where we're at 101. So we don't care. So our math value is we take the absolute value, which is going to be using the math operation ABS. And now inside of that, we're going to subtract two values. So we're going to subtract the x value. Now, when we're drawing sprites, remember we draw from the top left corner. The catcher game, we drew circles, and circles draw from the middle. But sprites, we're drawing from the top left corner because that aligns with the graphics. But we want to know the distance of their centers apart. So what we're going to do is say r1.x plus r1 half of its width. So we do w divided by 2. Now, each of our objects, our enemy as well as our player, both have x, y, w, and h. So width and height values. So we get to work with those. So we take that value. Well, let me close out and even out my parentheses here. Okay, so r1x plus half of its width, and now we're going to subtract from that. And what we're going to subtract is going to be r2.x plus r2. And as you suspect, w divided by 2. So that calculates our distance x. Now we repeat that same process for our distance y, ABS. It's always a nice idea, put in your closing parenthesis, r1.y plus r1 dot, in this case not width, we'll use, of course, height divided by 2. And then we'll subtract from that, put in some parentheses, backspace 1, r2 dot y plus r2 dot, of course, h divided by 2. So you can see these two lines are virtually identical, but one uses y's and h's, one uses x's and w's. So verify you have it set up. When we add that half value to our x and y, but then we're subtracting the x position of one from the x position of the other. So the middle operator should be a minus. Oh, let's align these with our comments there. Now we need to calculate our combined half widths, and we'll set that equal to r1 dot w divided by 2 plus r2 dot w divided by 2. And as you will suspect, our combined half heights will be equal to r1 dot h divided by 2 and add to that r2 dot h divided by 2. So that gives us the 4 values to work with. Now it's time to look for the intersection. So what we go is and say if, and it doesn't matter whether we check x first or y first, but we're going to check on the x-axis. So if our distance x is less than our combined half widths, so remember, as I demonstrated over in the example, that we have to be overlapping in both the x and the y-axis for a collision to be occurring. So we first do our option here. So if this is true, it's going to run the code that's inside of here. So we're putting an if inside of an if. So not an if else if. We're doing an if inside of an if. So we only will check on the y if it's overlapping on x. So if we're not overlapping on x, there's no reason to check if we're overlapping on y because no intersection's happening. So then we'll just go down and return false. So just y is less than our combined half heights. Oh, wrong one. And if we're overlapping on both, then we return true. So if we overlap on the x-axis and we overlap on the y-axis, we return true. But we only get here if both overlaps are occurring. Otherwise, it doesn't happen, and our intersect just returns false. Simple as that. Okay. So now how do we use this? So we are going to put this inside of our loop where we're looping through, where the enemies are chasing, they're updating and displaying, and we're going to then check and see if that particular enemy is indeed overlapping. And if so, I'm just going to make the background color turn so we can verify everything is working. Once we do that, then we're going to move on to our next stage, which is figuring out how we can kind of lose, and as we lose, move into a gameOverState. So what we can do right now is say if enemies k, well, we'll use enemies k there. I forgot what we want to say is. So we'll pass into this the player and the enemy. So we're checking if that particular enemy. So we say if rectangle intersect, and then we inside parentheses we pass to it the player and the current enemy we're checking. If that is indeed happening, then we'll just go fill, and I will say 0, 255, 0, 100. So that's just transparent green. And then we'll just draw a rectangle that fills the entire screen, 0, 0, with height. So these two lines are going to go away. Well, we might, maybe we want it to show a little flash when we intersect as well as we lose health to make it, less happy for the player. And I'm missing a right here. So I have an opening parenthesis, closing parenthesis, but I'm missing a second closing parenthesis. So remember, we always need partners. Parentheses and curly braces and brackets always need partners. So now I added in the partner. Now we can hit play. Avoid the unicorns. And we can see when it's overlapping. Ooh, look at that. And that's a lot. Now you may notice that the whole screen is not turning green. There's some unicorns on top. And that is because the particular unicorn that is running me over happens to be, I'm going to spread them out here a little bit. So we can see there's some particular unicorns that are later in the stack. So one that would be drawn on top as part of it. But I'm not too bothered by that. We get this uncomfortableness happening. And what I want to have occur when this little flash happens is now that we've verified our intersect is working, we'll let that guy chase and see the moment we overlap, there he is. So we have our overlap happening. I'm going to just turn that off. That's going to be real painful if it just keeps running in the background. So we have our overlap happening. Now what we want to do is we want to kind of reflect that with a health value or kind of a negative score on this. So we can do this in a lot of different ways. We can draw a health bar. We could just have a number show up on screen with it or any such thing. So what I'm going to do is I'm going to make a value that is going to be that value for my score. So let's add in this value for the score. So this will be an integer, but my score it's not a score I'm keeping track of, it's just going to be my health. Now we'll go in and add in health. I'm going to start my health out at 1,000. And what we're going to do is we're going to represent that by drawing a rectangle on screen that's approximately related to it. And every time there's an intersection, we're going to have our health go down by, I'm not sure what value I want yet. We're just going to start out with 1. And then we'll say if health is less than or equal to 0, then what we want to do is say our game state will be equal to game over, and close out that curly. So got a lot of curly braces here, so I'm going to put in some closing comments here to make sure we are keeping it straight. So this is and for, because we have our for loop happening here. Let's see, this is going to be our and intersect, and this one will be our and if. So I really think, as you're working your code, it's really important to keep those aligned and know what they belong to so we can find their partners, find their mate, check, make sure we're doing it. So that puts it there, but what we want to do is display that on our project. Now it just occurred to me, I I have my gameState variable and I have a gameState function. So I'm not running into a conflict here, but that's a really bad option. So my function really should be called playState, not gameState. So we don't have any type of confusion as to what is happening there. So I am going to make a change on that just because that I think is just problematic. But we don't have any, it's not breaking it. So if you jump ahead in the code and you wonder why it says playState instead of gameState, this is why is, it really is kind of that was a bad name on my part. Okay, so we've fixed gameState to playState. We're losing our health when that happens. Now we want to draw this on screen. So the way that I'm going to draw this on screen is I'm going to take that value and just draw it, knowing it would be so I set it to 1,000 for my health, and I want that health, and we don't need this intersect up anymore because we've proven that works. So I'm going to just draw a rectangle across the top of the screen, and I will make it 100 pixels wide. And that bar is going to then decrease itself as our health value goes down. Now, if you notice, I started health at 1,000, but I'm going to make it 100 pixels wide. So I'm going to take my health value and just divide it by 10 for how wide I want this rectangle to be. So to draw this on screen, I'll just put a comment in there for what I'm going to be doing. So to draw the health bar, I'm going to first do fill of 0. So I can draw some text. And I'm going to do a text size of 18. Make it a little bit smaller. And then I will say text. Oh, and I also want a text align left. Now, what I want to do is write out the word health. Actually, I don't need the colon there because we're going to draw something next to it. And I will put this, let's say 50 pixels over and 100 pixels down. And that will draw that on screen. So now, well, here we go. Let's run it again. So we can see, all right, we don't want to go down that far, so let's go 50. All right. Yeah, close enough. That'll work. All right, so now what I want to do is to draw that bar. So I'm going to say fill, and this time my fill is going to be, well, we're actually going to leave it at 0 for a moment. And I'm going to draw a rectangle. And this rectangle, as I draw it, is going to be, that's at 50, so let's go over, I'm going to guess 80, and then 50 for the Y. I know I have to change that, but I'm just going to start with this. And I want this, so I'm drawing the background rectangle first, and then I'm going to let the health bar, I'll draw kind of like a red to represent health on top of it in just a moment. So I'll set the width to 100, and my height, I am going to set it to 25. Let's see how that works. Okay, so we can see, all right, I need to move it over, and probably not 25. I'm going to, let's go to 20. And we need to go up on this. So, and I'm guessing on these numbers until I get it lined up. So at this point, I'm going to just try not 320, but 32. Let's see what this does. We can say, all right, that's pretty close. I want to come back and go over left a little bit. We can see, though, the game is actually playing that when I'm losing health, when I'm being intersected, and then it eventually goes on to, you know, game over. So that is happening. It is working. Let's just play again. I lost track of it because I was so happy it worked. All right, so I want to pull it down about or over a couple pixels. So let's try 16. Move left 4 pixels. Yeah, okay, I like that. Okay, now I'm going to set my fill to 255, 0, 0. And this time I'm going to draw it starting at the same position for it, but what we're going to do is the width of it is not going to be 100, it's going to be our health divided by 10. Because we go from 1000 to 100, so then that should line it up and the height will remain the same. So now if we run this again, we'll watch, we can see how the health bar goes down and then game over. Oh, XY with height, oh, entered in 50. I looked at the wrong number when I was typing that in. Okay, let's try that again. So we can see there's my health bar, and you can see how that health bar is decreasing. I like that. I'm not really liking the black. I'm going to choose purple for the background color. Let's just copy that. So fill, this is my background. So this is my bar background. Oh. Fill, and then this is going to be my health bar indicator. And instead of the red, I'm going to go with this color, kind of magenta-y. Paste that in. Let's refresh this and see how it's working. So we can see as they run into me. So I'm going to ditch where that green is happening, and or maybe make it just really, really subtle. So when that's happening, instead of making it at 100, let's just make it at, well, let's try 20. So it's a much more subtle. So we can see as I move away, so it's much more subtle. There's still a change happening, but it's subtle. Now, it would be nice when we're playing this game if we did have some type of background artwork, so we're not just drawing in flat gray. So if we put in a picture behind, that would be a nice improvement. So we've added in states, we've added in health, we've set it up so that we can lose the game. Now what we're going to do is keep track of how long you survive when playing this game, and then represent that time on the game over screen. So adding in the time of how long we're surviving. So we're going to have to do a couple of things. We'll have to draw that on our main screen here, which we have some text that we're not using, so we're going to draw that time. We'll maybe put it on the right hand corner of the screen and draw it over there. So instead it's drawn at the left. So now I'm going to just we'll put it over on the right hand side. So we're 800 pixels wide. So I'm going to just go at 700. So we're going to put that time in our string S. First step is we need to add in the timer. So you can go and just put a copy of the timer class from a previous project into this one. I'm just going to add it to this project. So adding in this class timer. So remember, classes always have our properties, our constructor, and finally they have methods. So properties are the things that will be used within the class. The constructors where we instantiate those values, and the methods are the things that this class knows how to do. So our timer is going to need two integers. It'll need a start time, and it's going to need an interval. The interval is how frequently we want it to tick. And then our constructor, when we utilize or make an instance of the timer class, because we can use it within our project, we don't have it set at a fixed interval, so we'll pass in whatever time interval we want that particular instance of the timer to be using. And then we set the internal interval value equal to that thing we passed in. So when we create an instance, we pass a value to it, and then that sets our internal variable interval equal to that. All right, so now methods. What does this know how to do? Our timer has two things. One, it can start. And the other method is it can complete. So two methods here. So we set our internal variable of start time. We'll set it equal to millis. Now millis is how many milliseconds the program has been running. So every time we launch our program, millis starts counting and it gives us a value. So what we want to know is what is the elapsed time, because what we're going to be able to do is calculate what is now the current time minus when we started, and then that gives us a value. So we're going to say int elapsed time, and we'll set that now equal to the current time. So every time we use the word millis like this inside of our program, it says how many milliseconds have currently passed since the program started running. So when we call start, it assigns the current time to start time. Now, when we're asking if our timer is complete, so we'll be checking, every program cycle if it's complete, and we'll then figure out our elapsed time is whatever the current time is minus when this particular start command was issued. Oh, there we go. And then what we do is we do a simple check. So if our elapsed time is now greater than our interval, that means, got to spell the word true right. We're going to return true. Else, we're going to return false. Easy as that. So when we use the timer, what we do is every program loop, we ask, hey, are you done? Hey, are you done? Hey, are you done? And when it's done, it returns true. And when it returns true, we do something with that. Whether we end something or we start over, whatever. In this case, we'll use it to start over. So we're doing it as a countdown on this. So we're able to, or a count up in this case. Looking at the code, notice we're missing a semicolon at the end of that line. Again, if you run your code, at times you will find that it's like, oh, you're missing something. So now we can incorporate that into our thing. So going back up into our variable. So again, we're up at the top here. So we'll timer. I'm going to call it clock, and then we need to store our time. So I'm going to have an integer, and I'll call it seconds. So now let's populate those. So clock is going to be equal to a new timer object, and we pass in the value of 1000. We want it to count in seconds, so we send 1000 milliseconds, or 1 second. We'll have seconds start at 0. So now that sets that, what we need to do is represent that and show it on screen. We also need to tell, we want the clock to start when we switch to our game state. So after we change our game state to game, then we'll say clock.start. We tell it to start. Now, let's go put some stuff in here on this. So let's go s is going to be equal to, and we'll set it equal to our seconds, plus, not equals, plus, and we'll go space and seconds. So that's now going to show us what is going on. Now we're not using the clock yet. Let's just look and verify that's working, and we can see, okay, it's there, but we need to move it over. So 700 is probably a little too close. So I'm going to go 675, not 6,000, 675. Let's run that again. Okay, that's better. All right. So what we can do with the clock is we can say if our clock, and now we call its complete method, if the complete method is equal to true, see, make sure I have matching parentheses so everyone has a partner. So if that method is true, we'll tell our clock to start over, and then we're going to say seconds plus equals 1. So that means every time the clock ticks, it goes up 1, 2, 3. And now if I move out of the way, they're not able to catch me. Ha ha ha. And now we can see how it's surviving. Now if we set the game that you couldn't leave the boundary, that'd be pretty bad. So we might have to set it up that you have more unicorns on here, making it harder. But it's your game. You can figure out how you want it to play. But it's enough. Again, we're doing proof of concept here, trying to learn foundational programming skills. So what I want to do now is in my gameOverState, instead of you survive for a long time, what we go, you survived for, and now we'll end that right there and go plus seconds plus, and now in quotes, put a space so it doesn't put it right on top of it, seconds, period. So now it puts our variable, our number will appear in there. Like I did call it seconds, right? Okay. So now let's see if that works. Void the unicorns, 2, 3. You survive for 3 seconds. Play here. Okay. Now you'll notice we don't have any type of replay built into it, but it was trying to replay, but then we didn't have a replay, so we will have to do that in our gameOverState. We're going to have to reset our game. But right now, you should notice that we've done quite a bit of getting everything working here. So we have that timer working, we have our health bar, we have our time representation with it. So now our final step will be to add in some reset. So thinking about the reset, what we need to have happen, that could be a utility function, but utility functions are more things that we can pretty much take these between projects. We don't even need to, we can just copy paste those in. We could even make a utilities tab and have it into it. It'd be then a separate file, and I could just move it from project to project. That'd be super efficient. But I'm going to just make a reset game method here. And now we're going to think about what things need to reset on this. So I want seconds to reset down to 0. I want my health to reset back to 1000. And now let's go up here and look. So we have health, we have our time. So the enemies don't, when they run into us, nothing's changing in them, so we don't really need to reset the enemies. We might want to reset the player's position. So if we look at the player here, the player starts in the middle of the screen. So what I might want to do is I might want to reset the enemies to these positions so they're not immediately overlapping the player, and reset the player back to the middle of the screen. So the best way to go about doing that is seeing if I have, by any chance, do I have a reset method? But I don't yet. So we're going to set a reset method. Currently we're on the enemy here. So we'll just see reset. And what reset is going to do is it's going to just reset our X and Y position. So I'll just copy that. But that puts it so if they were all bunched up in one particular place on top of the player, it now resets them back to a distributed position. Now let's go into the player here, and I'm just going to put it right up here at the top so it's easy to get to. So again, notice I hit return twice, closing curly, then up arrow, and now we're going to reset the player's position. So that resets the player, resets, then, well, it doesn't reset them, it gives us a method to use. So now let's go into our reset game over here, and now we can say p.reset. And then we need to loop through all of our enemies. So if we look, how do we loop through enemies? Let's go up here and look. So we just simply are going to use a statement like that. So let's go right here, paste that in, turn, close out my curly. So that's now the closing curly for this. This is going to be my and reset and 4. Now inside of this, we really only need one line, and what it will be is enemies K, so it's just like where we grabbed it from. We tell the enemies to reset themselves. So now let's try it and see. I'm going to let them all pile on top of me here in the middle. So if I push this button and the player is still in the middle there and they're all on top of me in the middle, see, we should see, all right, I made a reset game, but I didn't call it. So right here, let's gameOverState. Let's go reset game. So we can make a method, but we actually have to call it if we want to use it. So now let's run the game again. Now I'm going to move. I'm going to get them all to kind of chase me. So I'm trying to get them all pretty much into the corner here. I'll die down here. So the game ended with all the unicorns and me down here. So when I hit reset, I should see time back to 0, my health back up, and the player in the middle and the unicorns distributed. And voila, we've achieved it. We now have a state-based game where it's doing a lot of different things. It gives us a way to achieve a game over state. It's tracking our progress. It's giving us validation at the end. All those kinds of things that we like to see when we play a game. Good luck and have fun.